Hello, everybody. Let's continue our discussion about soil classification. So, first of all, I want to point you to our Canvas site. And if you click on this soil classification, you'll find the sets of slides we're using. We're going to go over all those slides together. And you will also find two handouts. One is the soil classification handout charts from our textbook, and pretty much the whole chapter for uh, the ASHTO and the USCS system. So it's a lot more detailed. So if you get confused at some part, you can definitely feel free to use them. And personally, I'm a very big fan of this figure 2.6 and figure 2.7 for the USCS system, and also 2.8. So they're really nice to use. Like, I use this a lot for my practice. Unfortunately, our FE reference book handout, or the chart in the FE reference book, does not really look exactly like that. It's way more condensed or compressed. So I think you should be able to use both and really get used to this one over here. So I will leave it to you, but as a minimum, you should be able to use this for the cell classification. So okay, let's get to it. So cell classification. Cell classification. So why? First of all, like, why are we doing that? Well, the whole idea is, hopefully, by using a cell classification system, all the geotechnical engineers or the civil engineers, they can talk to each other using a common language. And of course, we have English, but it would be really nice that we have a agreed upon terminology, or a set of terminologies to describe soil, so that when they communicate, we know what kind of soil we're talking about. So that's kind of the goal of this. And of course, different regions or countries, they would have slightly different standard, but by far, in the U.S. and also in the North America, that we're still overwhelmingly using the USCS system of soil classification. Uh, you probably have looked at this for a lot of times, which is good. I really want you to feel comfortable using or looking at boring logs, and this is a boring log from a consulting company in the U.S. And you can see that uh, this is a very clear sign of they're using the USCS soil classification system. All the COT sand SM over here, and the silt ML, and lean clay CL, and yeah. So basically, we have two categories of different soil classification system. So the first one is called a texture classification. So example of this is the USDA soil classification system. That this only consider particle size distribution. So the only thing you need to do is basically have a stack of sieves and do a particle size distribution, or do a sieve analysis, and you can get to the classification. Uh, Not the best system in the world, but it definitely has a lot of applications in agricultural or in that field. We don't really use this a lot for engineering purpose, but I do have a slide later on so that you would know how they do the USDA classification. The second system is the ASHTO and the USCS system. So we both consider both the particle size and the plasticity. So sieve analysis, on top of that, you have to do the outer limit test, and AASHTO and the USCS consider both of them. A little bit history of the USCS system proposed by Casagrande in 1942 for the Army Corps of Engineers. Got revised in 1952, and then now is widely adopted by geotechnical engineers. And we also have a standard from ASTM, ASTM D2487 for the system. So this is the ultimate guideline for this. ASTM is the ultimate guideline if there's any sorts of confusions in the future in practice. Go back to the standard and find the exact language for the classification. So first of all, let's take a look at all the symbols. So the symbols are basically break into all sorts of things. So some of them are pointing you more towards the texture, and some are more for the plasticity. So let's start with the texture side. So texture, basically particle size. G for gravel, pretty easy to understand. S for sand. M for silt. I don't really know why, but maybe M stands for medium. So silt is kind of something in the medium. C for clay, again, pretty easy. O for organic stuff, like pretty bad stuff. And then we're gonna jump onto the PT. Those are the worst stuff than organic. That is highly organic soils, peat. You don't really see O and PT a lot in practice, right? If you have those kind of soil on site, really good idea is try to get rid of them, and definitely don't want those kind of material onto your building or foundations. And then the right side of this, all the symbol, there are more, those H and L, they are for plasticity. So if you have something, have H, that means it has high plasticity. You have a L, that means it has a low plasticity. And for coarser material, and sometimes we also want to know their gradation. So you have a well for well graded and P for poorly graded. So a lot of times you will see a combination of this two GS on the left with W and P, because a lot of times those gravel and sand, they're non-plastic. So we want to throw a W and a P to G and S to look into the gradation side of those. And similarly, for M and C, for silt and clay, we care more about their plasticity. So H and L, a lot of times they're kind of comboed or more comboed together with M and C. So you're going to have MH, ML for elastic silt, and I think ML is just a silt. And also CH and CL for fat clay and lean clay. So, okay. Well, we will talk more about this combo later, and let's continue. So, this is the chart. I have this chart. This is a half of the gradation chart. Again, I'm personally not a big fan of this chart because I think it's a little bit too crowded. But this is the chart that our FE book is using, so I'm using this one here. Here's more of a practice problem that I want to go through this together with you. So there's really not much like technical discussion about soil classification. It's more about you sit down and have a very clear kind of some sort of procedure in your mind that, and then go line by line, and also be very careful about reading all those subscript. So as long as you're being very, very careful, and you should be fine. Okay, so here is the problem over here, and I have the chart up at the top. Also have an A line over here, so that you can look at. Anyway, so for a given soil, the following are known. Percentage passing through number 4 is 70. So 70% passing number 4. Percent passing through number 200 is 30%. And liquid limit is 33. Plastic limit is 12. And classify the soil using USCS system. Give the group symbol, which is this group symbol we're talking about here. And the group name. The group name is a name associated with a symbol. So pretty easy stuff. So first of all, recall number 4 sieve. So in the USCS system, number 4 sieve has an opening of 4.75 millimeter. That is the cutoff between gravels and sand. So you have percent passing through number 4 is 70%. So basically means the percent of gravel you have is, yes, 100% minus 70%. So the percent of gravel is 30%. So I can't really write on the screen. I've got my iPad at home today, but I hope you can write that down on your notepad or on your note, that write percent of gravel 30%. So those are all very useful information you're going to need for the soil classification. Just write down percent gravel 30. So we also have percent. The next given information, piece of information, is that percent passing through number 200 is 30%. So if the particle passing through number 200, which is 0.075 millimeter, that is fine, right? So write the second line, percent fine or fines is another 30%. Okay. So you have the percent of gravel is 30. You have the percent of fines is 30. And then the rest is sand, right? So this is just purely based on the particle size. So the percentage of sand is 40%, because 100 minus 30 is a 40%. So you have 30% gravel, 40% sand, and then 30% of fines. With that, let's go back to this table. Let's see whether we can do something here together. So first of all, do we or do we not have more than 50% retained on number 200 sieve? Well, yes, right? Because we have 30% passing number 200. So we have actually 70% retained on number 200 sieve. So this checks. So we're looking at the coarse grain soil. Now, let's go on here. Is it gravel or is it sand? So here's the interesting part. We have to look at out of the coarse fraction. Okay, so what is the coarse fraction? Well, anything that retains on number 200 sieve is the coarse fraction. So anything passing number 200 sieve is the fines. So out of those coarse fraction, do we have more than 50% retain on number 4 sieve, or do we have more than 50 passing number 4 sieve? So like come back to the numbers. Like we talked about, we have gravel, which is 30% of the total. And we have the sand, 40% of the total. And those are the coarse fraction we're talking about. And it looks like we have, out of the coarse fraction, we have more sand than gravel. So we have the 40% out of the 70% is sand. So we actually should go down here and check this box over here. Okay. And then let's continue. Do we have clean sand or sand with fines? Well, let's look at how much fines do we have. And coming back to, again, the number you wrote down, and we have 30% of fines. If you have less than 5% of fines, we're going to call this clean sands. Okay. And if you have more than 12%, which is our case because we have 30%. So we are looking at this one over here. Let's check this again. So I'm going to check this one as well. So we're talking about sand with fines. So you're probably going to ask, hey, what's going to happen for if I have fines more than 5%, but less than 12%? Well, there's a little superscript that you can read. I don't have it here, but you can find that table from our textbook or from the FE reference manual. That's where we're going to use something called a dual symbol. But read that, and not too hard to figure out either. So now we are down here, and then let's keep going. So now we have option 1, option 2. Do we have fines classified as ML or MH or CL or CH? So now we're basically talking about, are we talking about M? M, if you recall, stands for silt, or C stands for clay. Basically, are we talking about silt or clay? And if you remember the thing we talked about in chapter 4, the plasticity, they're basically asking you whether the soil is above a line or below a line. Okay. Or, if you don't really care about like above a line or below a line, just come to this chart over here on the left bottom corner and exactly point that point based on the adequate limit test results and find that out. Well, we have a local limit, 33. Yay. So that's good. So we can find our 33. I already marked it over here. So that's the 33 line. And then what about the y-axis? Again, it's a little bit tricky over here. So the y is pi. Again, it's pi, not pl. So we got to do a little bit calculation over here. So our pi plasticity index is 33 minus 12. So we're looking at 21 over here. So we should go back to the y-axis, find 21. Uh-oh. I think I did something wrong over here. So it should be 21 over here. And boom. So this is not correct. So see? Made a mistake. But anyway, so this is all good. And look at over here. This is CL or OL. We're talking about inorganic soil. So we're talking about CL over here. So the fines should be classified based on those two results at CL. So we keep going over here. And we'll have SC and classified as clayey sand. Okay. So you can pretty much put down the SC, which is the group symbol, and then put down clay sand as your group name. But I don't think we're done yet because there are still 3 superscripts that we need to check. So the superscripts are G, H, and I. So let's take a quick look at them just to make sure we don't miss anything for the group name. So what you do is that you can get out of this. Oops, that's loud. Let's get out of this and open up the handout from the textbook. And let's get to that page. This is the table we're talking about over here. And let's look at G, H, and I. So let's look at G. So if the fines classify as a CL-ML, you have to use the do symbol. Well, that's not the case. If the fines are organic, add with organic fines to group name. Well, that's not the case for us either. I, if the soil contains more than 15% of gravel, add with gravel to group name. Ooh, this is very interesting. And if you recall, our soil does have 30% of gravel. So that is more than 15% of gravel. So that this I applies for us. So go back to this one. So clay sand is not going to cut it. And we have to go back to this one and add a clay sand with gravel. So that's it. So here's the thing. So basically, yeah, so classification is just like a little roadmap. Make sure you write all those key information down. Make sure you read things clearly, and as long as you being very careful and thorough in the process, it's not really difficult at all. So yeah, so that's that. We can do one more practice, but I will just leave this to you to do it. And this one is on the fine grain side. So on the fine grain side, you are going to use this A line a lot. Make sure you read all the superscripts. Again, I can't fit this into the slide. Probably it's a good idea to have that table open on the side. And also, if you want to, it's also a good idea to use the table from the FE reference manual. I'm fairly certain that they're almost exactly the same, but just in case they are not, get yourself familiar with that table from the FE reference book. It's always a really good idea. Okay, so I have the answer here. It's pretty simple. CH, fat clay. Basically clay with high plasticity. Okay, so let's move on. And again, personally, this is my favorite table to use. A very clear kind of a roadmap. Again, as I said, I use this a lot in my own practice when I was practicing, but because now you don't really have access to this during FE exam. So, I don't know. Like, I hate teaching to the exam, but just want to make sure this thing's out there. Will make your classification actually a lot easier. Okay, so let's move on to there are more practice. So again, I'm more than happy to do this together with you, but how about you pause the video for a couple minutes and use the chart to do the classification, and then you can come back to this video for the answers. So maybe just pause the video now and do the classification. Give yourself about a few minutes. Okay, so we're back, and as you can see, all those are here, and all those figures are probably not very accurate because I'm not sure whether they're using the right version, but it doesn't really matter. We're talking about do symbol CL-ML. -ML, and the group name is sandy silty clay. So hopefully you get it right. And same thing over here. Only tricky part is that sometimes they will give you PI directly, which is actually pretty helpful. And if they happen to give you just the PL, make sure you calculate PI, because that 8-line charts is based on LL and PI. Same thing, pause the video, do your own classification, and then come back to the video to check your answers. Okay, now we're back. So hopefully you got this one right as well. So this is ML. I'm sorry, this is an MH, and it's elastic silt. So that's basically what MH stands for. But because it has a significant amount of sand, so you will have to include the with sand as well. So you might have missed this part, but doesn't matter. Make sure you read all those superscripts very carefully. Okay, so more examples, but again, this one is practicing using the chart that I like a lot. And the thing about using this chart is you don't really have to read any subscripts or superscripts, which comes in very, very handy. You can also use this one. I have all the answers for you as well. Again, another practice. So yeah, so a lot of practice for sure, but you'll get plenty of a chance to do that in your homework. So in this video, we'll just move on. Okay. Okay. Let's talk about the Ashto system. I'm pretty sure Dr. Lindgren had talked about this a lot in the 212 class. My personal comment on this is that they are overwhelmingly being used for from the FHWA, Federal Highway Administration, a lot of state DOT. I should say a lot. All the state DOT, they adopt this as well, and so this system is specifically designed to evaluate the soil for roadways. So the definition or the application is pretty narrow, but it also has its own uniqueness as well. So this is something that as a geotechnical engineer or a civil engineer, you should be very familiar with as well. So it's not as complicated, I would say, as the USCS system. So it's just one very simple chart. I also are pointing you to the ASTMs and the AASHTO standard, just in case you want, if someday you're going to work in the lab, and I'm pretty sure you're probably reading this every day, or, finish reading this in the first couple months of your training, and you should be all set. Okay, so excuse me for that. And it's a very simple cross section of a roadway, and we're talking about more of evaluating the subgrade, which is basically native soil. Subbase, sometimes you have it, sometimes you don't, but we're mainly talking about how suitable your subgrade soil is for a construction of the road, and also together with the traffic load sitting on top of it. So yeah, we have some like load distributions when your load travel pass through, and basically all those repeated load will create compression when the load is off, and then will create some suction between the soil. So a lot of times you want your subgrade soil to be really well drained. This is definitely all sorts of problem will happen if you have a subpar subgrade. You could have some of the migrants of the very fine particles into your the whole pavement system, which creates all sorts of problem for drainage things like that. So we're not going to get into the nitty gritties of that, but that's kind of pointing you that in the Ashto system, they really, really care about the fine content. They really care about the plastic limits, uh, mainly because their system are using on the soil that's specifically supporting the roadways. Okay, so let's look at the system. Systems in general, you have very similarly a granular material at the top, and they are rated from excellent to good. So granular material, everybody loves granular material, not surprising. All the way to A4 to A7, that is fair to poor. Not really a big fan for roadway, and so to for granular material, we're talking about at least 35% or less passing number 200. Okay, so um, their definition of granular material is a little bit different from our, I should say the USCS definition of granular material. So in the USCS classification, as long as you have 50% retained on number 200, you're generally in the granular. You're a granular material, but the AASHTO definitely has a higher standard of what can be called granular material. So 35%, that's the magic number. In silt or clay material, you have more than 35% passing number 200, you're going to be classified as a silt or clay material. So another little bit difference between AASHTO and USCS is that we in the USCS system we don't really absolutely have to have number 4 and number 40. You have to have number 200 and also you have to have number 4. So, but in the AASHTO system, you absolutely have to use number 10, number 40, and number 200. Okay. And after that, you also need to use the LL and the PI, which is very similar to our USCS system. So LL and PI. And same thing here. So basically, it's kind of similar that you just look at the number you have for number 10, number 40, number 200, and then just go through this one by one and then find where you are. Okay. We can use some examples, but basically, like here, like 50 max. Okay, so you can the percentage passing number 10 for A1A is 50% max, and also has a plasticity index max, which is 6. So basically, you have to just go through this one by one, and you will find your fit. Okay, and that's pretty much about it. So like, we can get an example. We can do this, but that's kind of how you classify the soil. There's one more thing that is you need to have something called a group index calculated as well. You can write down those two equations, and I'm pretty sure the FE reference manual have them as well. That you need to, apart from doing all this, you also have to include a group index. Okay, and look at this equation and how we do that. Well, this F200 over here is the percentage passing through the number 200C. So if you have 30%, if you have 20%, then use that 20 or 30 in this equation. Okay. Liquid limit, PI, pretty standard. There are some things you have to read this pretty carefully. If you have a negative value for GI, okay, use 0. Straightforward. Okay. And you have to round them off to the nearest whole number. So if you have a 3.4 GI, use 3. If it has 3.5, use 4. Also pretty standard. Number 3, there's no upper limit for the group index. Okay, so whatever number you get, that's the number you get. Next one is if you have pretty competent soil. So if you have A1A, A1B, A24, A25, and A3, your group index is always going to be 0. So if we come back to this, so basically, if you have A1A, A1B, all pretty nice, good material, A3, A24, and A25, anything here, their GI is always going to be 0. Okay. That said, if you have A26, A27, all the way to A4, A5, A6, to a bunch of stuff over here, you're gonna have a GI that is not 0, and you have to report that GI using this equation over here. And there's another one that is if you are doing A26 and A27. So those two up here, you can use this 5.2 equation. Okay, so it's a little bit easier, but you're going to use this group index over here. So there are a lot of rules, but I think nothing kind of just easier than just go do an example. Okay, so let's look at this soil A over here. Okay, I want you to write down all those numbers so that we can go back to those tables. So you have a percent finer. Well, when they talk about percent finer, that basically means percent passing, right? You have 83 passing number 10. You have 48 passing number 40. And you have 20% passing number 200. You have a LL of 20, and you have a PI of 5. Okay, so we have all those numbers. Let's go back to the table, and let's do that. So let's look at this table over here. Number 10, you have a 83. So 83 is definitely not going to be A1A because it's 50 max. So let's move on to the next one, A1B. Oh, you know what? First of all, we should look at the granular material, right? So that kind of dictate us whether we're looking at something on the top or we're looking at something at the bottom. So passing number 200, we only have 20%. Well, less than 35. So we are looking at this top one over here, granular material. So we're looking at an A1, A2, or A3. And then we'll just start with the A1 one by one. How about A1B? So A1B passing number 40, 50 max. So we have 48. So we are good over here. And how about number 200? Oh, 25 max. Well, we have 20. So we check this box as well. What about the liquid limit? Well, there's no requirement for A1B, and the PI needs to be less than 6. So we have 5. So we're good over here. So we're kind of lucky that actually A1B is the material we're looking at. Okay. But if you feel free to check all the others, I'm pretty sure the only one would fit our soil is going to be A1B. Okay. For example, all those A2 material, they have a very, 10 PI max and 11 minimum, and also they have liquid limit that is, in the realm of 40 or something. So those definitely won't work. But anyway, so we have A1B, And if you recall, the group index for A1B is going to be 0. So the answer for this material is going to be A dash 1 dash B, and you put the group index in the parentheses just right after your soil. So that is your definition. Oh, that is the classification using the AASHTO system. Okay. Definitely try that again for B, C, D, and E. Kind of just practice that a little bit, and I have all the answers for you. And some of them, for example, the soil B, you do need to check the group index. So do that on your own, and then compare your answers with the answer key over here. And you should be good to go. So again, there's really not much to it other than just kind of be very careful, and you also have plenty of a chance to practice them in this homework. And yeah, let me know if you have questions or struggle with a specific one. I'm happy to go over with you coming Monday. Okay. So last one is the USDA system. So it's really a system that we don't use. So, but in case you have to use them somehow, I don't know how, but here it is. So we define 3 categories. That is sand. Has a pretty weird definition of the diameter of the sand. 2.0, 2.05 millimeter in diameter. And silt is from 0.05 to 0.002 millimeter in diameter. Good luck doing SEAL analysis on that. But anyway, clay smaller than 0.002 millimeter in diameter. So in USDA, we don't do anything that is larger than 2.0 millimeter. So they struggle a little bit with the gravel component. They did some modification to accommodate that. That is, if you happen to have some gravel, you have to plug in this equation to do a modified sand, silt, and clay content. But anyway, let's say you don't have gravel. You're kind of lucky. If you want to use this material for agricultural, you probably don't want much gravel in them. Agriculture, if you don't really want too much gravel in them anyway. So you do that, and then you're gonna come up with the 3 percentage, and then they should total up to be 100%. Let's say, for example, that you have a material that has a 50% of clay. Realizing I'm covering this material up, but so this is 50, and you go this line over here. That's 50, and then you also have about, let's say, 11 something percent of silt, and you kind of come this way, and then the rest is 40 or 30 something percent of silt, and then that will put you into here, and that will be putting you into this weird shape of material, and the B over here is clearly clay. Very simple, clay. And yes, you could be putting into, depends on your texture or sieve analysis. You could be like a sandy clay, clay loam, silty clay loam, silty clay loam. So you get the idea. Okay, so this one again, only this classification system only looks at the texture and nothing else. So, and also, like, as long as you see the name loam, it's a pretty good indicator that someone is using the USDA system, because neither AASHTO nor USCS will say something like loam. Okay. But anyway, so that's it for this one. So also pretty brief. Hopefully, uh, this will serve as a some sort of review for the classification system you have really learned from 212, and also um, hopefully will point you to the right resource you will be able to use for the homework and for the classification system. So that's it for today, and thank you so much for your time, and I will see you the coming Monday. Enjoy your weekend.